Miss, can you hear me?
Yes.
Okay. I just bought a new mic. Let's test it out.
Okay.
Miss, for the part A, I think I mostly complete already. Just the part B, I still trying to figure it out. Part B is quite hard. Um, when is the due date for part B?
Supposed to be submitted by today
Ah, but the semester until May, but submission so early.
because you want to prepare for your final year project also, right? So I want
Yeah,
you
I'm
to
doing.
focus on for your
Yeah.
final year project. That's why I put the deadline is earlier so that you have more time to focus on your final year project. Your Viva is on 17, right?
Um, 17th of April, I think so.
Uh, so if you finish mine earlier, so you can have time to focus more on your final year project.
Yeah, but to be honest, I think the networking assignment part B, I think for me is a bit harder than FYP, because FYP I already prepared for some time already.
I see.
Miss, but can you help me to contact the UOG people to put up the submission so that I can submit also? Maybe I can submit the part A first if they want to.
I try to contact, but if possible, maybe after Raya.
After Riot. So I just submit to Spark first.
Uh,
Okay, okay. But after Riot, UOG site still won't overdue, right?
I don't think so lah.
Okay,
Because
okay, sure.
if you submit earlier, I check if there is any issues. At least I can give you feedback so that you can do it for correction
Oh,
and so on.
okay, sure.
So good morning, students. Today we're going to continue our topics. Okay, as last week we already learned about ATM over IP address. Okay, so now we go for active congestion control, where we will use the last week networks, which is ATM network, as a case example. Okay. So congestion in ATM. Why does the congestion control is needed? Because when we involve statistical multiplexing, it will be under assumption that the users does not transmit at their peak rate simultaneously. Therefore, your traffic demands are stochastic and cannot be predicted. Therefore, your congestion is unavoidable. Whenever the total input rate is greater than output link capacity, congestions will occur. Okay, when congestion occurs, the queue line may be large in a short time that and causing buffers to be overflow and your cell will be lost. Okay, therefore, congestion control is necessary to ensure that users get the negotiated QoS. So this is the common misunderstanding related back to your congestions control. Okay, so congestion is caused by a shortage of buffer space where the problem will be solved when your memory became chips enough to allow very large buffers. So okay, so usually the large buffers are useful only for short-term congestions and cause undesirable delay control long delay. Okay, large buffers postpone the discarding of cell but cannot prevent it. Long delay introduced by large buffers is undesirable by some application. Number two, It will cause also by the slow link, where the problem can be solved when high speed link is available. Increasing in the link bandwidth can aggravate the congestion problem, because when you have higher speed link, it can make your network more unbalanced. Okay. So for a given switch, high speed link outbound reduces congestion, but a higher speed link inbound can make the congestions in the switch cause worse. Okay. So the third one would be your slow processor. Okay. So the problem can be only solved when your speed of your processor is improved. Okay. Faster processor can transmit more data in the given time. If several nodes begin to transmit to one destination simultaneously at their peak rate, the target could be overwhelmed. Okay, so congestion actually is a dynamic problem, therefore it requires some dynamic solution. Simple static solutions such as increase your link speed are not sufficient to solve your problem. Okay, previously we already discussed three main issues, right? Which is buffer shortage, insufficient link speed, and processor speed. So this three actually is the symptom, okay? Is the symptom, not the causes of your congestions. Okay, so we need to identify the characteristic of your application. Different application will show different characteristic. Okay, so for example, the differences would be the characteristic of the data transmission and QoS requirement. Therefore, for you to transfer over your ATM network, you require service classes to be defined. Okay. So, what is actually the quality of QoS parameters? You can see we have cell transfer delay, where it is a delay experienced by a cell between the transmission of the first bit of your cell by the source and the reception of the last bit of the cell is received by the destination. Okay, the second one, you're going to have your maximum cell transfer delay, which is the worst case is your CTD value. Okay, and mean CTD, the mean of your CTD value. Okay, so peak to peak cell delay variation, where it will be the differences value of your maximum and minimum CTD experience when the connection is happening. So actually CDV is end-to-end QoS measure, while cell delay variance tolerance is a measure of burstiness allowed across your UNI. So if you don't remember what if UNI, you can refer back to last week slides. Okay. So usually UNI is involve only user and the router. Okay. So cell loss ratio is actually the percentage of your cell would be lost in the network due to the error or congestions. Okay, so now I give you few times, around 15 minutes to find out what would be the differences between CTD, max CTD, min CTD, and also CDV. Okay, please do
Okay.
come back and share me the information.
My mic is still working, right?
Yes.
Okay.
So how was your findings? Did you get any information?
Yep, roughly.
Can you?
Yep, wait. So there are differences. Maybe I will start by what is actually the meaning of each of those acronym term. So the CDD max is actually basically telling us the maximum time a cell can take to reach its destination, which means it represents the worst case delay scenario. So the CDD mean is also similar to max, but except that this one is more pointing to the average time taken by all cells in traffic stream. Yeah, so it helps us to predict agak-agak like in averages the typical delay. Max is like the worst, mean is like average time that we use to forecast. And then the CDV and then CDVT. So CDV is the cell delay variation. So that one is basically the variation between the longest and shortest cell transfer delays in given stream. Yeah, so very similar to the jittered concept that you have mentioned before. And then the CDVT, the cell delay variation tolerance. So this one is like how much how much limit that is allowed for the cell delay variation lah. So and then the lastly is the CLR, so the cell loss ratio. So this one is basically representing the percentage of a lost cell compared to the total transmitted cell. So yeah, so it indicates the network congestion and reliability basically. Yep, that's all.
Okay, good. So I hope you gain a lot of informations and it might help you for your case study later that
Yep,
you are saying that it is hard. Okay. So next we proceed with the usage parameter. So usage parameter usually it will be negotiated, okay, when your connection is set up. So these parameters actually will govern your transmission behaviors of your user's application. Usually your network can only provide your QoS for the cell that adhere to this specification. So there are few specification. You have PCR, SCR, BT, MBS, okay, and MCR. So PCR is actually the maximum instantaneous of rate at which the user will transmit. This one is the peak, okay. And then sustained cell rate, SCR, is the average rate that is measured over a long interval. Okay, then we have our burst tolerance, which is the maximum burst size that can be sent at your peak rate. The maximum burst size is the maximum number of back-to-back cells, okay, that can be sent at the peak cell rate. So you need to know the calculation here, which is your burst tolerance is equivalent to your MBS minus with 1 times with 1 over SCR minus with 1 over PCR. Okay, and then you're going to have your MCR, which is minimum cell rate. So UPC is the usage parameter control. Usually this action was taken by the network to do the monitoring and control the traffic at the end system access. So next, this is the service classes that I have mentioned just now. In previous chapters also, I have mentioned some of it. For example, is your real-time variable bit rate, non-real-time variable bit rate. And then we have our constant bit rate already mentioned previously. Okay, the new thing here is your ABR and also your UBR. So ABR is actually a quality requirements that use the capacity of your network when it is available. Okay, then the example of the ABR is your critical data transfer. It can be your remote procedure call and it also can be your distributed file service. Okay, for UBR, okay, it is use any leftover capacity and does not have any CTD, CDV, and CLR constraint. Okay, so the example is your emails, okay, text messaging and news feed. So this is the adaptation layers, okay, which is we have learned last 2 weeks, which is AAL 1 until AAL 5. Okay, for each of the adaptation layers, they have different bit rate. Okay, and it also using different constant rate. Okay, for example, in PCR and CDDT, okay, they have specified for each of the CBR, VBR, ABR, and UBR. Okay, so take note that number one, it will represent the maximum rate that which your sources can send. Okay, and that may not be subject to your connection admission control, where this one we will cover later, and also your UPC. Either it is explicit or implicit specified for your PVCs or SBC. Different values of CDVT may be specified for the SCR and PCR, minimized for sources that adjust cell flow in response to control your information. So, just now I have mentioned about your control admission controls, a connection admission control, CAC. So this one actually is an action that taken by your network during your call setup to identify whether your connection can be accepted or not. If your connection cannot be support or cannot be accepted, they will do the rejection for the request. Okay, so the algorithm for CSC, actually we identify whether it is enough resources for the connection or not. For example, they will ask, is there enough your bandwidth? Is there enough your buffer space along the connection path? Okay, so all of the decisions to answer these things, okay, will influence based on your service category that proposed by your uh, service category, okay, and then your QoS requirement that being specified and the state of your networks, okay. So actually your CAC algorithm is responsible for route selection and resource allocation if your call is being accepted. It will include your statistical allocation calculation for BBR services, okay. So here you can see that the requirements of different service classes. Okay, so CBR, no congestion occurs as your bandwidth is reserved in advance, where they will perform end-to-end signaling. So therefore, when you use CBR, congestion will have prevented. Okay, then VBR, theoretically, they have no congestion will be occurs because your bandwidth is statistically being reserved in advance, okay? But due to you use the statistical multiplexing, okay, several boosty application will transmit at the maximum transmission rate, okay? That may cause a short-term congestion to occur, which can lead some cell loss. If your algorithm of CSC is correctly being used, your actual CLR is less than requested or negotiated CLR. Okay, and then ABR congestion would occur, but need to continuously identify the amount of your bandwidth available for the service class. So this goal for the ABR is to transmit just the right amount. Okay, ngam-ngam lah, to use the available bandwidth efficiently, yet not to build up your queues along the route. While for UBR, the congestion would occur, but it can be prevented by dropping your UBR cell. Therefore, no congestion management mechanism is needed. Therefore, your congestion can be avoided. So, the differences between constant and unspecified is your constant would use the prevention, while UBR you will use avoidance. Okay? Where your UBR actually will only use the bandwidth that is unused by other service classes. Okay? Therefore, it doesn't know how much it is available. So, if the bandwidth is not enough along the journey, so your cell would be dropped. Okay, So this is the bandwidth allocation. This is from the previous ATM lecture that I have shown previously. Okay. So the one that is having a strike to almost 100% is the example of the behavior that your result when two VBR application with different burstiness transmit simultaneously. Okay. So let's have a 15 minutes break before we proceed.
Okay.
Okay, now let's proceed. So ABR cell allocation. So ABR is used the leftover bandwidth that is from the higher priority services such as your CBR and VBR, where your cells are transmitted when there is capacity and queue at the senders when there isn't. Then the feedback will be sent back to the sender. So ABR standards does not require CTD and CLR to be quarantined, but it is desirable for switches to minimize the delay and loss as much as possible. Control loops control, closed loop control. Okay, so the ABR service requires switches to constantly monitor their load and send this information back to the sources which then dynamically adjust their transmission rate. So the regulation is achieved by periodically inserting your resource management cell into your traffic flow. These are then updated with congestion information by the switches and destination and sent back to the sources. Okay. So this is the identification of your RMC. Okay. So the ATM cell header contain 3 bit of packet type fail. That is to indicate the type of your cell. As you can see, that is the example on how does the representation looks like. Okay. So F4 flow control operates in your virtual path management plan. Okay, while for your F5 flow control operates the virtual channels management plan. Segment flow is between the adjacent devices, while end-to-end flow is between your ATM source and destination devices. Okay, so this is the RMC contains several fields that is used to control your ABR congestion. Okay, if your field is header, they will use PT or VCI. Okay, if they have the ID, they will check based on the protocol that required to be used. For BN is the backward notifications. Okay, DIR is the resource management cell direction. CI is the congestion indication. Okay, if set congestion will be encountered. Okay, and no increase. Okay, used to signal the sender if it is allowed to increase the ACR. ERs is the explicit rate where it is used to update the sender's ACR. CCR is the source current rate of your cell's transmission. MCR is the source desired minimum cell rate. Okay. Next, this is the closed loop control using RM flow. Okay, this is just an overview. Okay, the switches along the path update your CI, ER, and NI field of your RM cell to indicate the rate that the source should be used after receipt of your RM cell. Okay, so the blue one, you can see that is the RM cell, while for the white one is your data cell. So closed loop control using RM cell is your operation where we will start with our initialization using initial cell rate. Then the transmission. Okay, so insert transmission, periodically your RM cell is inserted inside the flow. Okay, where you will involve these three lah. Your CI is equal to false, your NI is equal to false, your ER equal to ACR. So usually your switches can set your CI or NI to true if they find out there is congestion. And they can reduce the ER to reduce the transmission rate. So the destination also can change this value if it detects the congestion inside your VC. So congestion can be detected by monitoring your EFC in the EFCI. Okay, in the cell header that the switches can set as your cell passes through. Switches and the destination nodes can also generate additional resource RM cell and send them directly to the source at any time. Okay. Therefore, there is no need for them to wait for the next source generated by RM cell, and the new cell does not have to travel the full round trip. Okay. Next, this is the unregulated flow. If you can see, when they go through the bin, okay, that have leaking, it will become a regulated flow. Okay. So the leaky bucket mechanism for the congestion control is an abstraction of the idea in achieving a regulated output flow when the arriving flow is unregulated and varies freely. In order that an actual mechanism can be built based on this abstraction, a few simple rules can be identified, which is the bucket has a fixed capacity. Okay, the bucket hold tokens, not the input data stream. Okay, the rate R at which token are placed in the bucket is fixed for a short term. If your bucket is full, arriving token will spill over the edge and lost forever. Okay, while arriving data are queued inside your buffer, each of your cell that passes through the mechanism takes a token out of the bucket. A cell may not pass if your bucket is empty. Therefore, they will wait inside your buffer. Okay, so next. This is the how does the leaky bucket mechanism was what we said illustrated. Okay, so packet in stream. Okay, they will queue. The packets will wait until a token is available. Once a token is available, okay, they will use a packet to remove the token. Only then the packet will be streamed out. A packet are placed in the bucket at the rate of R token per second. Okay, so your bucket can hold up to B size of your token. Okay, so this is the differences of the grafting. Okay, where before they have the tokens, which is unregulated input flow, and then you going after you use the leaky bucket mechanism. Okay, you will get a regulated output flow. Okay, so the leaky bucket configuration in terms of ABR, your R will govern the sustained transmission rate, while for big will govern the maximum burst size. Okay, R and B will together govern the peak flow over a short time period. Okay, so if it is over a short time, if for example they have said over 3 second period, peak flow is, so you're going to times your sustained transmission rate with 3 seconds, only you can add with your maximum burst size. Okay, so the feedback in your RM cells is used to update the values of your R and B at your sources. Okay, and then this is a simple work examples. Okay, the questions one. For a leaky bucket system with the following characteristics. So your B is 20. Your replacement rate R is 30 tokens per second. Okay, so what would be the minimum and maximum flow in 5 second period if the arrival rate of your cell range is from 20 to 40 per seconds? Okay, so you have to do the analysis first. Okay, you need to make sure that you are taking out the information correctly. So they said at least are tokens available for each second. Right? Okay. So where does the R token came from? It is from your token replacement rate. Okay, that one is 30 token per second. So you need to have at least 20 cells per second. So that one is for your bucket size. So minimum flow in 5 seconds is how much? Is 100. Okay, so if your bucket initially full and they are B plus 5R. Why 5R? Because we have 5 seconds. Okay, cells available in 5 second period. So the maximum arrival rate exceeds 200 cells over a 5 second period. Therefore, a maximum of 170 cells can flow in a 5 second period. Okay? So far, do you have any questions?
So far, so good.
Okay. So next, this one I want you to try to do. Okay? Um, Later when you go back, try to do it at home. Now I want you to proceed with your coursework. Okay? So share your screen and I want to see your progress. That is all for the topic for today. So now I want to see your progress for your coursework.
Sorry, just now suddenly.
Just share your screen and do your coursework.
Miss, okay. But the part B, just let me read the question first. I the part B, the images. Do you have a like HD version? It's a little bit blurry. The figure one.
I don't have it. It is only that was shared. So I only have that version. Don't have any other version.
Okay, okay. Let me try to figure something out. So later on, I clean up the format for the part A. Then I will submit maybe around tomorrow or Tuesday, and then need to trouble Miss to help me check a little bit if I need to change anything. So if no issue, then should done half of that part, then I can focus on part B already, like at my final year project.
Which lab that you haven't done yet?
All done already, basically.
So I think you can just share me your PDF files so that I can check. You can
Can?
send me through email first because Spark currently I don't think it able to um accept the submission of PDF. It can accept, but when we lecturers want to download it, it got issues now. So
Oh,
you can
okay.
send me through email first. If anything, I will reply, give the feedback through email.
All right, sure, no problem. Let
So
me
I hope
let
I
me
can.
let me format everything first because it's quite a lot of pages. I need to like format one by one first.
I hope can I receive feedback today?
Uh, I today I cannot promise honestly, because I already 48 hours no sleep already. After this, I need to go straight to my bed a little bit at first.
Oh,
But
okay.
I will try to make it Monday or Tuesday.
Okay.
Miss, if I eventually the part A, I think I follow all the instruction correctly, right? And then I get a pass mark at there, but my part B did not do correctly, will I still get a pass for this subject?
No.
So basically the part A is like a must, and then the part B also need to how does it work? I don't understand the marks for this subject actually.
For part A, you must do it all of the labs, only
Mm-hmm.
considered as pass. Half of the coursework is pass. So
Mm-hmm.
if your part A is not being fulfilled, so automatically, even though your part B is pass, the whole courses you will be failed.
Mm.
But if your part B is wrong, but part A is pass, you still fail for this subject. So how do you get your coursework part B is pass? You have to understand the rubric that have been stated inside your coursework. They have a rubric there.
Mm. Okay.
Anything else?
Should not have any question yet.
Oh, okay. Then I release you earlier so that you can have time to do your formatting of your labs and have some times to do your coursework part B. Okay, I hope I can receive it maybe next week before we going to have 1 week of Hari Raya break. By I think is this week before Friday. Is it possible for me to receive at least half of your part B lah?
Part A confirm lor. Part I will try my best lah. If worst, then maybe.
Okay, but I will try to stick with UOG first and see.
Okay.
Okay.
If it is possible, let me know the due date so I can plan it out more accurately.
Oh, okay.
All right. Thanks.
Okay. Bye.